In part 1 of this two-part series, we constructed a Bayesian belief network in the world of hang gliding, fed it with cases from previous flights and then validated its correctness through various queries. What we didn't address in part 1 were some actions that we might want to take to improve the safety record of our club. One way of improving safety records of any group of people is to eliminate the presence of people in the group who contribute to an unsafe culture. One of our pilots, Boaz, is in that category. He takes unnecessary risks and has already had a few accidents. So we decided to hold a special members meeting to discuss and decide by vote whether Boaz can continue to fly with us. So imagine the meeting has started. One of the pilots who feels strongly that Boaz should leave wants to convince the others that she is right. What information would she show to back her claim? How about a log of all the flights made by Boaz in the last few months? Here's where our discussion gets a considerable boost, because we can use our Bayesian belief network to tell us what it thinks about Boaz's performance. All we need to do is to go back one step and unlearn the cases which we originally provided the network with. Remember that apart from the prevalence node, the network started off with no real values inside its nodes. Following that, we fed it with a table that had cases performed by several club members. So what we will do now is use the same network, and simply load it with Boaz's last flights. We go through the same procedure with the new table, and now have new numbers. These are nothing less than a 100% objective answer to the question, is Boaz a safe pilot or not? When we last ran the belief network with a mix of flights from all of the club's pilots, the assessments whether our group of pilots was on the whole responsible showed a belief of 82.5% of being responsible. Look now at this same node when the data is based exclusively on Boaz's record. We learn that he is only 41.7% responsible, and indeed, 58.3% less responsible. So using the club's Bayesian belief network, this speaker was able to make her point precisely and objectively for everyone to see. More people agree now that there is a problem with Boaz. But some members are saying that while safety of flight is very important, also other aspects of Boaz's personality such as his social abilities and also his overall contribution to the club, should be factored into the final decision. So here's where another feature of Bayesian network comes into play. As we can see at the left top of the chart, we have added another network module, with a node, in blue, for deciding whether to remove Boaz from the club or not, connected to a utility node, in pink, which we named Club Meeting, and which we will soon see in operation. We also added 2 more nodes that reflect the other things that people wanted to factor into the decision on Boaz. This is how the utility node looks on the inside. It has 4 columns on the left, 1 column for each parent node, and 24 lines for each of the possible combination of all the states in its parent nodes. Column 5 has values associated with some selected combinations on the left. It doesn't matter if not every line has a value associated with it, however, only lines that have values will be considered in the decision. The values themselves can be any number that represents a level of conviction that the decision that appears on column 1, whether it's stay or go, is a good decision for that line's combination of parameters. To illustrate how this works, look for example at the top line. What it says is that a combination of a responsible pilot, with good social behavior, and doing an excellent job of supporting club duties, will most certainly stay with a conviction value of 100. On the third line from the top, this member would still be allowed to stay in view of being a responsible pilot and having good social behavior, and in spite of not contributing with club duties. Because of that last issue, however, the conviction that stay is the right choice is weaker than on the first line and carries a value of only 70. Similarly for the 6th line from the bottom where the decision is for a member to be expelled because of a less responsible personality. This is in spite of having good social behavior and excellent contribution to club duties. However, notice that the value on column 5 is only 20. So there's little conviction that this is the best decision. Yet still, the decision is a go. It should be mentioned that the lines of the utility node can also be thought of as different opinions expressed by members in the meeting, hence the node's name, Club Meeting. As for the effect of the utility node on the decision node, we can currently see a score of 25.74% for a stay, versus an 18.07% score for letting Boaz go. But what if now, someone in the audience suddenly brings up a new social issue that we didn't know about? Boaz's social behavior rating just got a little worse, and the effect of that, passing through the utility node to the decision node, is now almost a draw between both decisions. Now assume that the discussion continues, and someone else in the audience tells everyone, to Boaz's credit, that when it comes to club tasks that nobody wants to do, Boaz always volunteers. This will lift the rating in club duties up a bit, and the end result for Boaz is stay. So to summarize, utility nodes reflect the subjective assessment of the decision maker. Possible scenarios carry decision values, with higher values indicating more desirable outcomes. The specific values assigned to utility nodes depend on the context of the decision problem and the preferences of the decision maker. One small note on the technical side, without going into the details, let us just mention that the final choice is the highest rated decision, calculated as follows. First, each line that has a value associated with it calculated as the multiplication of all the current network probabilities of the states on that line, times the value chosen as the line's level of conviction in column number 5. Then, the scores of all the lines that have a common decision state are added up, and the decision is passed to the decision node together with its total score in the table. These are the numbers displayed next to the alternative decisions in the decision node, from which we pick the one with the highest score. One can also choose to show just the decision that got the highest score, without the numbers.